Welcome. In today's episode, we'll discuss arrays, tuples, and sets, which are ways to store values. We saw the values and the variables in the latest episode and the different types, but we only saw like single values stored in variables. Today, we will see how you can store multiple values assigned to single variables, which is quite useful. So let's get started in Python and Grasshopper. Okay, so we are in the desktop. I already showed you last time how to get this set up. So let's start right in. So in order to create a list in Python, we write the name of the variable as we did last time, and then you use the square braces, and you can within the square braces you can write values. So let's say two, let's say hello, let's say maybe I don't know 3.14, and then let's say true. And as you see, then let's print this list, and let me print it. Of course, I have to write the name, print x. All right, and you see the list. And as you can see, you can write any type in the same variable, and this is quite powerful of Python. You can't do this in other languages because they're typed, so they wouldn't force you to use the same type in each element of the list. In this case, you can just mix them up. So let's create a new list, and let's just use numbers in this case. So let's say 1, 4, 5, and 7. And yeah, of course, you can also do the same type. And in this case, this would be a more actually a more coherent way of defining arrays. You can use different types, but it's not very advised. So yeah, when you code, try to stick to single values if you can in an array. Okay, just I wanted to show you, you can also use round braces, and these will define a so-called tuple. So let's say this is a tuple, and this is an array. So array, actually, it's a list. List and array are kind of the same thing. It depends on the language. In case of Python, they are. So though it's a list. The difference between the list and a tuple is the way they're stored in RAM. So a tuple is faster because you can't add elements to a tuple. So you see a tuple now has 4 elements. You could have 5 or any element, any amount of elements you want, but you can't change it later on. So in this case, I could do X. I could add something to our array. So let's say I can append something. So added element. All right, and then if you print X, you see we added an element to an array. You can't. There's no way you can do it with a tuple. There's no function that allows you to do that. All right. So and then there's a third type. Let me show you by maybe writing 7 again in the tuple. Let me print the so I print the array. I will print the tuple, and I will print this third thing that I defined right now. And this third thing is a set. So I say S is, we can do it in 2 ways. So let's use the curly braces and define it. We'll do it like this with the right set. And if I try to print it, you see that this number got ignored. That's because a set, you can't have duplicate values. So this 7 was found 2 times, so 1 was just dropped. So this is not actually allowed. Let's just remove it. And yeah, the set, it has just unique values in it, and you can have any value. Like you could be this could be a string. That's fine, but you can't have duplicate values. That's not allowed. So the other difference between these 3 ways of storing multiple values is that in case of the first 2, so tuples and lists, they are ordered. What it means ordered, it means that to access the different values, you can do it by their index. So let's say x of 0 is the first element, so it would be 2. X of 1 would be a low. Actually, let me just try. So let's say x2 equals x1. So the first element is x of 0. That's because the first index is 0. X1 is the second. And then let's say maybe xn, we want to get the last element of the array. You could do it either by dropping in a 3 in this case, or by writing -1. So it will start to count at the end. So let's print the 3 values, x1, x2, and xn. and take a look at them. And yeah, that works. And of course, you can do it with the tuple as well in the same way using the square braces. All right, let's stick to the list, which is fine. Okay, so we already saw how to add elements to a list. Let's also remove an element from a list. I haven't mentioned it, but as said, you can also add and remove elements from it. A tuple is just the one that you can't do that on. So let's do x dot. No, I mean, we saw that append adds an element. So let's say append added element, and then we will do x dot. Well, actually, let's do first. Let's remove the last element first. So we will remove the true. That is done through x dot pop. So pop removes the element from the array, and then we will just print. Let me just not add anything at the moment. So I will comment the line of code. I will print x, and if I print it, you see that true is gone. And if you write a number here, it will pop the the element at that index. So in this case, 2. So the 0, 1, 2, it removed 3.14, and indeed that is working. You can also insert elements at a specific, so insert elements at a specific index. You see it prompts you for an index, let's say 2, and then maybe 1 actually. Let's choose a different index. And then we could add something, let's say we have false, okay? And then you print it, and you see at index 1, so 0 before index 1, so in between 0 and 1, it added, so before a low, false was added. Okay, and then you can use append, as we saw before, to add elements at the end. So let's do that. We added an element at the end, and then we can also ask, like, what's the length of the array. So to do that, we use len and the len function, and we drop in the name of the array, and then L, and indeed 6 is the name is the length. And let's also print back the array, and yeah, there you have it. You have 6 elements in the array. We got the length. All right, so this is pretty much it in Python. So you could also use other functions, and we will see them with time. But at the moment, I'm satisfied about this. So let's now go to Grasshopper and see how to handle lists. So we saw already the panel last time where we could put in single values, and the same way as you do in a list, you can also like hit enter. So go to the next line and write other values. So let's say hello, let's say true. And now this contains a list, well, sort of. This actually, it's just a string at the moment. If you right click and you hit multi-line data, then it's a list. So now you see the indices and values in the list, and you can also give it a name. If you right click on the name, you can just say maybe list, well, L, okay, or list. Let's maybe use big letter L. Okay, so as we can do in Python, then you can go to sets, and we could access an element. So let's say this is a list, and yeah, this is the list, and then we have the index. Let's say we want to access element at index, well, index 1, 3 is not available, so let's drop that in. Let me remove volume so it doesn't prompt at me. Okay, yeah, 1, and then we can print the output. In this case, it's a low. If we go to 0, it's 3. If you go to 2, it's going to be true. And by default, if I go ahead, it will wrap around. That's because this wrap is set to true. If you want to set it to false, you can either right click and set false, or use this Boolean toggle, which we didn't see last time, but let's show it today. So you can drop it in here, and then if you double click, it becomes true. Double click again, it becomes false. And if you use an index which doesn't exist, it will say that this supplied index doesn't exist in the list. Let's bring it down and find it. Okay, so this is like the same as using the square braces to access a value. Let's see how we can add values to the list. So you can have a list here, and you can have a new one you can add. So added value, and to do that we use the merge component. So merge, we take the first one, and then we take the second one, and indeed it automatically creates a new input. You can delete it, you can also leave it there, it doesn't matter. And then you see you added another element to the array, and you can also remove elements from the array. And the way you do it, there are different ways actually. Let's say we will use the split list. in order to do that. So I will just go here and go here and then say I want a certain index, in this case maybe 2, and that has to go away. So let's do that, and indeed we will get the first list, which is just the list the the last element, because we supplied 2. Otherwise you can do this, you can also ask him the element that you removed. Okay, and you have also different ways to do this. You could also use actually this list item component. Let's do that as a test. So let me move around. Okay, let me right click, disconnect, right click, disconnect. And you can write the indices that you want to keep, in this case 0 and 1. Drop them in like this, and you'll see that in the output you get just the 2 that you supplied. So you can also use lists as inputs to keep the elements. You could do 0 and 2, 0 and 2. You will keep the first and the last one instead of just removing the last one. All right, and you could also create a series instead of doing this. Let's do that so that we can see another component. So the other component is the list length. And indeed, writing list length every time, or like a list item, is kind of boring. So there's a way you see if I write li, list item comes up automatically. And to do that, if you go on the list item component, you right click, you can set an alias, and you see I set li, and then I confirmed. So now when I look for components and I write li, it's the list item, ll is the list length. Okay. And so we can ask the list length. Well, we don't need to duplicate it. And indeed, the list length is going to be 3. Let's add another element, added. And then the list length is 4. So if you want to remove the last element, what you could do is you could create a series. Let's do that. That starts from 0 by default, goes increments of 1, and it adds the length of the array. You see we get now 0, 1, 2, 3. This keeps all the elements of the array. If we use minus, we will see operations in a future video, but I will use just this minus. It's pretty easy to understand. -1 in this case. So the list length -1 is now 3, and if I drop it into the count, you will see that we get these 0, 1, and 2, which are the indices we want to keep. And then if you drop it in the index, you see we removed the last element from the array. There is also a way to add elements, so there's insert item here, and yeah, I guess this was pretty much the main components. Of course, you could go look up other components. I will just discuss them briefly. Shift list just takes all the elements and moves them by 1 index. So the one at 0 becomes at 1, the one at 1 becomes at 2. So it moves them by a certain amount, not necessarily 1, maybe 2 or 3. And then you could use reverse list that like inverts the order of the list. And yeah, you could sort it based on some like ascending or descending order, and we will use these components with time. It's not necessary to discuss them all at the moment. I'll just like show you where this serious thing came from. It came from here, and you can duplicate data as well. So you can take like a list, duplicate it. Let's show it maybe here. Let's take this list, duplicate it a number of times, by default set to 2, and you will see that here the list is like 1, and then again it's duplicated. So you can do a bunch of operations on lists of numbers, of course, or any type. Actually, we only saw the basic types here, but you can also use other types. So let's draw maybe a couple of curves on the scene just to show that you can do it. Maybe let's draw a point, and let's draw a vrep. Okay, so we have 3 objects now there. Let's use the geometry as we did last time. Right click, set multiple geometry, enter. And indeed now we have this geometry which is containing the list. And then we can inspect it, and you see we have a reference planar curve, the reference point, and the reference extrusion, which is just a vrep, but it's just a specific type of vrep. So you're not limited to use basic types. You can use the added types as well, and if you defined other classes, you could also use those. All right, I guess that was it. I just want to show you one last thing, because you may it's kind of counterintuitive, so I will show it there. So let's say we have an array, um, a list in here in Python. Actually, first let me show that there's no tuple in Grasshopper, but there's a set. So let me show the set for a second. So sets are in here. You can create a set, and you can create it from a list. So let's try to list, and then let's use numbers 1, 2, 3, 4, 5, 5, 6, 6, 7, 7, and okay, right click, multi-line. Let's actually maybe um, just so that, I mean, they don't have to be, of course, ordered. Let's say 5, 5 again. Okay. Bear in mind that keep in mind that if you leave a space at the end, you will add empty values. So you don't do that. Okay. Of these values, you create a list. And indeed, if you drop into the set, the duplicate components were removed the same way as in Python. Okay, so let's go back to Python and go ahead with the last thing I wanted to mention today, which is about lists. So we have this list, and let's say we want to access an element. We want to find the index of hello, for example. So let's say x.find, and we will find hello. Maybe it's index, actually. Yeah, I guess it's index of hello, and then we will store this in a variable, call it I. Okay, and then we can say print I. We expect to see, well, 0, 1. Okay, let's print it, and indeed we get 1. So this is a very easy operation in Python. You will see that in this list thing, there's this item index component. So you may be tempted to try it out, and let's actually do that. So we will take our nice array. Let's use it. Let's take this array. Okay, you drop it in and you say, okay, I want to look for hello again. So let's do hello, and we expect to see 1 as an output. So let's drop it in. We go to hello and we get a -1. So the reason why this is happening is that this element is not meant to look for this kind of uh, values defined in Grasshopper. It's meant to look for the GUID we were looking at last time. If you drop in a GUID of an element, that will find it in a list. But if you want to look for the value, you actually have to use a different thing called set, called actually in the set panel, which is the member index. Okay, so this will be sort of the same thing. You drop it into the set, and then let's go 1, let's go to the member, and indeed now it shows 1, and if you write true, it will tell you 2. So you have to use this member index instead of this list item if you want to look for elements in the list. I'm not sure what it does if you write it multiple times. Let's try. I believe it gives you the first appearance. No, it actually shows you both appearances. Let's also check what it does in Python, because I don't remember. I guess, yeah, you can't provide multiple values here, but let's say we have two hellos. Let's see if we get a list as a response. No, in case of Python, it just looks and tells you the first occurrence. Instead, in Grasshopper, it gives you both occurrences, or all the n occurrences of that element. So if you want to look for an element in the list, use the member index, not the item index. It's a little bit not intuitive, but that's what you should do. Okay, so that was it for today's episode. So I hope you find it useful. If you did, leave a like, follow the channel, and see you next time. Bye.